In Lab 3, we are trying to calculate the mass of a black hole based on given motion about a star orbiting around it. To do this, we determine the net force to be only gravity and that no other forces are involved in changing the motion of the orbiting star. Using data derived from the motion of the star, we can separate the forces into parallel and perpendicular forces and then use that to calculate Fnet and then the mass of the black hole. We are going to use Newton's second law to derive initial and final velocities, and therefore momentums, to calculate dp over dt in finding Fnet. Then, we will use Newton's law of gravitation to solve for the mass of the black hole that would cause the force of gravity calculated by Fnet perpendicular. For the result, we see that the mass of the black hole is just below 3 times 10 to the 31st power in kilograms. That's pretty big, about 15 suns mass equivalent. Now we will see how I calculated the data. Overall, we're trying to find Fnet and separate it into its perpendicular and parallel forces. We see here that the blue line represents the change in position of that star that orbits the black hole, which is the red dot at the bottom of this graph. Since the motion is not a perfect circle, we can assume that the change in momentum parallel will not be zero, which we can take into account later. For the Python code to model the data, we first input the star's mass and then the change in time to be 1 day. Then, using the star's position data, we will calculate V initial and V final, and therefore P final and P initial. After this, we can use this data to collect delta P, and therefore dB dt, which happens to be equivalent to Fnet. Then, we find the P hat and the magnitude of the momentum to find the parallel component of the dB dt, and therefore parallel component of Fnet. Then, dP dt perpendicular will be dP dt minus dP dt parallel. Therefore, Fnet perpendicular will be dP dt perpendicular. Now we've found all the values we need. We will run the code. We see that the yellow line represents Fnet, the black line represents Fnet parallel, and the blue line represents Fnet perpendicular. We can see this because Fnet perpendicular points toward the change in direction, Fnet points towards the black hole, and Fnet parallel faces the direction of motion of the star. The most important value we found, however, is Fnet. Using Fnet, we will import it into Newton's law of gravitation equation and find the second mass, which is the mass of the black hole. It checks out. The model is able to predict the mass of the black hole based on the positions, therefore velocities, therefore momentums, and then therefore forces, which can be used to solve for the mass. What does it mean? Fnet and dP dt and the respective perpendicular and parallel forces will be equal in quantity, however, but different in meaning. dP dt shows the actual change in how the star moves, while Fnet and its respective counterparts show how the star's motion is affected. What if you were to replace the black hole with another black hole with a different mass, but the motion of the star given didn't change? Would we be able to tell the different mass? Technically, if the mass was changed, the motion should change according to the forces of the black hole. And since gravity is the only force acting, we would not be able to tell. Thank you.